Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 3 from the February-March 2020 Pure Mathematics P2 paper from Cambridge. This is 9709, and this question here is about integration. And here we have to integrate, or we have to find the value of a, which causes the integral of 2 over 2x minus 5 with respect to x between the limits of a and 3a, to give us ln of 7 over 2. So here we have an integration involving a fraction. Now when you've got a fraction, the first thing you should try to look out for when you have to integrate is check to see if you differentiate the denominator, does it give you something of the same form as the differential of the numerator. So if you differentiate 2x minus 5, you get a number 2, okay, a constant. The numerator is exactly 2, so it's exactly the same. Even if it was another number, another constant like 3 or 5, any other constant, it would still be able to, when we have that with respect to x, we end up with 1 over that function as it is, then multiplied by the differential of what's inside that function. This is the chain rule basically. So you end up with the differential of what's inside the ln function divided by what's inside the ln function itself. So you see this form, you know that it's the result of this happening. Okay, so we can reverse the chain rule and we can go backwards. So what we can do here is we can say, okay, let's start integrating this straight away. So we have I always like to write down what's up there, because sometimes it doesn't cancel out fully, so you'll be able to find the fraction or whatever very easily this way. So just write down 2 times the ln. Now one of the things we have to realize is the input of the ln function can only be positive. So we have to put the ln of the modulus of f of x. Now there's a bit more to the modulus of 2x minus 5 in this case. Okay, and then we have to divide by the differential of what's inside the function, which is 2. As we see, they will cancel out here, and we're left with this, and we have our limits of 3a and a. And when we find that value, it's going to give us the ln of 7 over 2. And we have to find the value of a that makes this equation true. Okay, so we have to always write the modulus. Now I've explained this in more detail in some other videos. But I mean, we must write the modulus. And I'll put a link up here at this time, which is 2 minutes and 37 seconds into the video. So just make a note of that. Okay, so I'll put a note or a link, okay, for at the top here at about 2 minutes 37, you'll see a link there which you can click, which will take you to a video which explains why we write the modulus as part of that question. Okay, so now I'm going to put the values of a in here. So I have the ln of the modulus of 2 times 3a minus 5 minus the ln of the modulus of 2 times a minus 5 is equal to the ln of 7 over 2. Okay, be very careful that you don't miss out anything or write something incorrectly. So now we have the ln of 6a minus 5 minus the ln of 2a minus 5. Now that should be the modulus, sorry. A is a positive constant, but we still don't know exactly what it is. So we should keep writing the modulus, because it could be that the input could still be negative, and so we have to put the modulus sign there, ln of 7 over 2. Okay, now what I can do is I can use the laws of logarithms. I know that if I have the ln of p minus the ln of q, it's going to give me the ln of p over q. Alright, using the division law. So I can do the same thing for this. I can have ln of the modulus of 6a minus 5 over 2a minus 5 is equal to the ln of 7 over 2. Okay, so now I have the ln of something equals the ln of something. Is one term and one term. These two must be the same. Okay, these two must be the same because they're equal to each other, and here you have ln of something equals the ln of something. So that means that 6a minus 5 over 2a minus 5 must be the same as 7 over 2. So now I can solve this equation. I can multiply both sides by 2, which will give me 2 times 6a minus 5. I can multiply both sides by 2a minus 5, cancel on this side, and we'll end up with 7 times 2a minus 5. And now I can expand, so I have 12a minus 10. 2 times 5 is negative 5, negative 10. 7 times 2a is 14a. Minus 7 times minus 5 is negative 35. Now I have to bring the a's on one side and the numbers on the other. So I have negative 10, I'll add 35 to that. I have 14a here, I'll subtract 12a from both sides. So now I'm going to get 25 is equal to 2a. So therefore we can say a is equal to 25 over 2. So it tells us that a is a positive constant. It is, so that's fine. So a is equal to 25 over 2. There is the solution to our equation. Okay, if I put 25 over 2 into this, it should give us 7 over 2. Alright, so there's the answer to our question. Question number 3, I think there's just one part to it. Okay, so the important thing is when you see a fraction and you're integrating, the first thing you should check for is, has the ln function been, is it the result of the ln function having been reversed in its differentiation, the chain rule. Okay, so there's the answer. Other questions from this paper can be found in the playlist, which will appear in this section over here. You will find my the playlist for integration. Okay, reversing the chain rule integration. I'll have a special playlist for my P3, and the P2 questions will also be in there, of reversing the chain rule integration. Okay, you can subscribe to my channel by clicking on this link, and you can watch this video. It tells you how to find my content, and where to find things that you are looking for. Thank you for watching, and see you soon.